Okay. Sorry. Trying to address all the problems. All right, 39 people. Shall we wait a couple more minutes?
Yeah, I guess so.
Thanks for helping us with that, Sanan. We got it working. Or
You're
I
welcome.
got it working. We can help Joy a little bit more, I think.
I think it's just a downloading issue because the binary still shows Mac. Thank you. Actually, now that we're waiting a couple more minutes, I'll mention the background graphic. It's actually from a game where everything's on an infinite grid. So if you fall, you infinitely keep falling. And this is just like a looking up as you're falling. Manifold Garden, I believe is the name.
Some interesting periodic boundary conditions there.
Yeah.
Yeah.
If we could see beyond the boundary between the multiverses, that's what we would see.
And I'll start at 15. Like I mentioned, this talk is mostly going to be about the library side of PyBioNetGen. I'll explain what that means momentarily. And I kept it pretty short because one of the main thing that I just want to show is just the features that we have available at the moment, which, this is basically an alpha piece of software where it's wrapping around BioNetGen as lightly as possible. But we have a lot of improvements in the future that we have in mind. So this is just, trying to start using it, see what the problems are when we use it, when we release it to the users, which, as you can see from Slack, there are many. And one of the main things I want to mention, and I'll say this a couple times. So that's a really good question, Michael. So it's basically a stack of multiple things. The actual simulators are in C++. The BioNetGen side is in Perl. And at the moment, the Python layer is actually on top of that. Eventually, my hope is that there's only going to be the Python layer, but we're slowly replacing the Perl side, basically. Okay, I think I'm going to start if that's okay with everyone. Let me make sure that I have my stuff open. I think I saw someone with a plotting issue. Not I think, I know I saw someone in the Slack with a plotting issue. I honestly get that with the laptop I'm working with right now actually has normal GPU on it, but I'm using the internal CPU for the GPU because the GPU is getting old and it's breaking basically. And I'm actually having trouble plotting as well. I'm pretty sure it has something to do with VS Code GPU acceleration. Just, if anybody's having problems with using the interactive plotting, just wanted to let you know that was as well. Okay, I think I'm just going to start now if everybody's ready for that. Okay, so can everybody see this?
Yes.
I'll do this so that it's a little easier to see. I'm going to minimize you guys so that I can see what I'm doing. Please interrupt me. You can talk, chat. This is, like I mentioned, supposed to be more of a, I'm going to do things. You can follow along with this. And actually, so one question for everyone. Did everybody download the GitHub repo for the workshop? Before I continue. Yes, no? Okay, so let's start with that. So I'm going to post a link to the chat right now. This one. And we're going to copy this. Let me just start from scratch then. So I'm going to go up a folder. 1 second. Let me do it this way. Yeah, that's fine. So we are in some random folder. It doesn't matter where we are. Let's wait for this to open for a second. So what I'm going to do is I'm going to hold Shift, Control, and P, which is going to bring up a prompt like this. Then I'm going to start typing git, and we're going to get this git clone command. And then I'm going to press enter.
Sorry, what do we have to press?
Control Shift P. You can also go.
Where do we press it? Where do we do that?
It's whenever you have the window open.
But I did that in the terminal window and it didn't work from the terminal window.
It still should, as long as you're within VS Code, that should take precedence over everything else. There's an option to disable that. Unless you manually disabled it, it should be okay. So is anybody having trouble with this? It's Control Shift P. That should pop up in a window, and you start typing git, and you get to git clone.
It's command on the Mac.
Yes, it's command on the Mac.
Control is a separate thing from command.
Okay.
If you do not have git clone, you want to click on this extensions button over here, which is Control or Command Shift and X, and then you can start typing git over here, and then you should have git automatically, but I actually don't know. I think this comes by default. I would be very surprised if clone is not there. Do you have the latest version of VS Code? Because I'm pretty sure it comes by default. I didn't have to install anything for this. Huh. Do you happen to not have git working on? No. I'm very confused. So if you go to your terminal, if you write which git, if you get git working like this, you can also just type git clone over here and then just paste the link. That also works. You don't have to do it like I'm doing. I thought that was standard in all VS Code, but maybe I'm wrong. So I'll write the command separately. You can go to the terminal and type this, or you can do Shift P, Shift Control P. If I can hide the window, there we go, and start typing git. I go to git clone, and I'm going to type copy paste the link that I posted. When you do this, it will tell you which folder you want to install it in. This is just my user folder, so I'm going to press enter, and then it's going to clone. I will come to the extension question in a second. I really thought it was just a default thing, but we'll look at it in a second. So it's going to tell you that, hey, you've cloned a repository. Do you want to go open it up right now? And I'm going to click on open, and it's going to open up a new window, close the old one, where the workshop folder that I just downloaded is my main folder. It's going to populate in a second. You should be able to see these on the side. So for Git extensions, I am deeply confused because it shouldn't.
It says it ships with VS. It says it ships with Git, includes Git out of the box.
Yes.
In the box. That's from.
So you shouldn't need any extension.
Mm.
There we go. That's the problem. You don't have Git installed for some reason. What OS are you using? Okay. That For me, it worked immediately, but you might have to install it separately.
You might need Windows subsystem for Linux or something.
You don't need that. Okay, so the other option is the following. Let's do this as well. And if this doesn't work, unfortunately, I'm gonna have to move on, but I'll help you later in Slack. So if you go to this website, you can come over here to code section and then just click on download zip. You can then download this file. Sorry, I'm not showing you the screen. You can go to that website and there's a green button, well, green for me, that says code. And when you click on it, it should open a window that says download zip. You download the zip and then you extract it. Yes, that one. And when you extract it, you can open that folder under, if you go to file and open folder, and you just need to click on that folder. Extract wherever you are. And then you just need to open it with this open folder command. It doesn't matter. Whatever is good for you is fine. Whatever you want it to go. Whichever directory you want is fine. It could be under your downloads, it could be under your documents, whatever you prefer. So once that's open, okay, we haven't done this yet. So we want to go to the extensions section again, which is over here again. It is going to be Control-Shift-X, and you want to type Jupyter. And this should come up with this Jupyter extension. If you don't have this installed, install this extension, because this is what we're going to use if you want to follow along.
Can you go over that again, that last bit?
Sure. So there's a extensions button over here.
Okay.
And you can also get to this with Control-Shift-X or Command-Shift-X, and you just type Jupyter in the search bar, which would pop up with a bunch of different extensions. But there's this Jupyter extension at the very top.
Okay.
If you click on that and click on install, instead of here disable, you should see an install button. You just click on install. And then once that's done, you should be good to go. If you've ran PyBioNetGen models before, there shouldn't be any issues left after this. But let's wait until, I'll wait a couple more minutes to see if any other issues pop up, and then I'm going to continue from here. Oh yeah, this is a good one to showcase as well. I'm going to wait until we are 26 to see if there's any other issues. Then I'm going to continue. Fantastic.
George, just a quick question. Where do
Yes.
we find the workshop 2021? That's not a Git repository, we just clone, right? Whatever you have it on your SV open now?
Yeah, so basically what you're going to do is to go to File, Open Folder, and find the copy, the cloned repo that you have. I don't exactly know where it's cloned or copied. If you use the VS Code's like command, it tells you, do you want to open now? And if you haven't done that, that's perfectly fine. You just need to find the folder after clicking on this and just find where it is. I unfortunately don't know where it's saved for you, so you're gonna have to find it, but
And it should be a Git repo since it was cloned
Yes.
from a Git repo.
yes. If you have Git working, again, you know, some people might not have Git running. You might have to install Git separately for Windows. That's kind of a pain, but you can look up on how to do that if you just search for Git for Windows. But if it's working under source control over here, you will actually, as you change things, you will find some changes to the files that you make. But so once everything is installed, I would like to continue a little bit and I will answer questions as they pop up. But what you want to do is to go under this PyBioNetGen folder and PyBioNetGen folder, and you should find the pybng.ipyynb file. Whenever you click on this, it's going to pop it open. And If you haven't selected a Python interpreter yet from within VS Code, it's going to ask you, hey, which Python interpreter do you want? And then you're going to click on that, and it's going to find all the Pythons that is installed on your computer. It pretty much finds everything. And you want, if you followed along with my suggested way of installing it via Anaconda, it's going to be something like Anaconda bin Python. But basically, you need to select the Python that has PyBioNetGen installed here. If you don't know which one that is, you can do which Anaconda on your terminal. I will do that in a second, and figure out where that is, and that will tell you which Python it is. But you want to select this one. Perfect. Thank you. So whenever you want to do, whenever you want to check this, you can go to New Terminal. Oh, if you have selected it already, it is not a problem. If this first cell doesn't work, we can figure that issue out. But if you click on this New Terminal, if you don't know which Python it is, you can come here and say which PyBioNetGen, and that should show you where it is installed, and that tells you like which binary, which Python you need to select. Basically, this apps Anaconda 3 bin 1 is the one that I have PyBioNetGen installed. So,
So Sinan,
yes.
how do you get that new terminal icon over there?
Which new terminal icon?
Oh, I'm sorry. I was looking on your toolbar on the left-hand column over there. It looks like there's a little terminal. About the fifth one down. That looks like a little computer screen.
Mm-hmm. So it's just a notebook. I just opened up the notebook. Let's start trying to get this cell to work, and we can kind of debug any issues that might pop up.
Okay.
So what I'm going to do is I'm going to click on this first cell. And then I'm going to do Shift Enter here. And it's going to pop open a Jupyter server at the bottom, as you can see. This is going to use the Python that we just selected. And if you haven't selected one, it's just selecting a basic one. It probably has your PyBioNetGen installed. It probably has only one to select from. Or you might have selected a default one as well at some point. That's also an option. So once the server's open, it's going to execute the cell. I don't know why it's taking so long. I'm pretty sure it's because my computer is getting old, and it's having trouble with both Zoom and this. But so you need to have the Jupyter Notebook extension installed. It's over here in the extensions, and you search for Jupyter, and there's a Jupyter extension. You need to make sure that this is enabled.
Yeah, I have it installed,
Mm-hmm.
but it's still not working.
Do you have, okay, maybe we need the Python extension as well. Yeah, that might be that might be another thing.
I'm going to restart it.
I don't think you needed this, but you might need this Python extension as well. So you might want to search for Python and install that as well. I thought it automatically installed, but I guess Jupyter's.
Yeah, that's not installed for me.
Okay. That might be another reason.
Hey, Sinan, I'm getting no module named PyBioNetGen.
So that's the selection of the Python.
I did that, and along the bottom of my screen, it says it's the right version, the one I expect. And when I run that Python from the command line somewhere, I can import PyBioNetGen there. Anyway, I don't want to hold up your tutorial. You can just keep.
We can do one more thing. 1 second. Pretty sure you can do. Give me 1 second.
Okay.
It'll take 1 second. I'm pretty sure. If this is like a last resort type thing, I don't like doing it this way, but I'm going to do this regardless. So you're gonna do this. I'm gonna copy paste this in the chat. You're gonna want to do this. Well, not NumPy, sorry. Of course, it's PyNetGen. I'm going to show this in here as well. So if you do this, if you execute this cell instead of NumPy, of course, PyNetGen. If you execute this cell, it should install it in whatever Python it's running. Because the only way that that's going to happen is if it's not installed on the same Python. And for now, this will sort out a lot of the problems. Okay, so I'm going to execute this. That's going to give me.
How do I make a new cell to put that in?
Oh, the new cell button is over here. It's a plus, insert cell.
Ah, okay, got it.
Okay. So there's some text. I'm basically just going to be talking about this instead of, if you want to read it, there's some links embedded in the text as well. But basically, PyBioNetGen is like two portions. One of them is a command line interface, and one of them is a library. They're one and the same at the end of the day, but you know, I'm using them for different things. The command line interface is being used for running these models that you've been using. You can also use it to quickly run models on your own. And this library is designed for, really quickly, you developed your model in VS Code using the extension, and now you want to do something with it. You want to import it, and you want to run some simulation, get the data, and start plotting it. And this is to really speed that process up. At its core, PyBioNetGen is like a good way of installing BioNetGen. That's a very simple way of doing it, but also it comes with these nice features, or at least I hope it's going to be really nice for people. Like I said, it's more of an alpha version of the model of the library. It is reasonably robust. It is working pretty well on every OS that I've tested so far, but it also doesn't have an immense number of features. So here, I do want to ask you, if you want a feature, if you wanted to be able to do something that you can think of, please let me know, either in Slack or just post it on the GitHub site under the issues section. That will be ideal if the issues section, but if you post it on Slack, I'll probably put it on the issues myself. Right, so the first thing is I imported BioNetGen as PyBNG, and I'm going to be referred to it as PyBNG for now. There's actually another package called PyBNG. They're not related. I just wanted to be easy for now. And the main entry point is this run command. And this is a very simple convenience function to run a model. This is the same thing as passing the BNGL model to BioNetGen itself. The nice thing is saying, sorry, try Control-Shift-P, select Python interpreter. Yeah, there we go. Sorry, Python, select interpreter, and you need to find the Python that you've installed. Sorry. So yeah, this run command. The nice thing about this run command that I like is it will, if you don't give it an output folder, it will run it in a temporary folder, and then it will load in every result you have in a results object. So when I run this, you will see the BioNetGen output, and you're going to see this. You're not going to see any files because it just creates a temporary folder and runs it there. I'm going to make another cell under this. And I'm going to show you that if you look at these results, you have all the files loaded. There's another way of running this, is that if you actually put an output folder, so I want to do this first, and that will run under results SRI. And if you go to results SRI, you will see the files that are being generated. One thing to note about this is that the behavior for this particular call is to put you in the folder that you ran everything from. This is for interactive analysis, designed for interactive analysis. That behavior might change, but this extra code you're seeing is about being able to go back to the folder that I started from. So I have some comments about that, but it's not, as you can see, if you look at the current folder, we're actually in the SRI folder, SIR, sorry. And the results are basically loaded as what's called a NumPy record arrays. You'll see how they behave momentarily, but if you want more information, I put a link there. And this is something that I changed very recently. If you haven't updated your PyBioNetGen, you will get some errors, and it's actually because of this, because I wanted to make this a little bit more user-friendly. So when you print the results, it will tell you what is loaded and what models it's loaded from. You're going to see that we have a CDAT file because this is every species, and GDATs is the file that contains all the observable results. One way to access these things, results.gdats, and you can key it with the name of the model. So if I execute this, you'll see some results from it. These are multiple, so you have time, and then you have the 3 observables. You can also key it with an index, and this will default to GDAT files. So if you want to access not GDAT files, you have to look at them separately. And the options right now are CDATs, so the CDAT for all the species, and it also reads scan files if you're doing parameter scans. So that's one thing. So one thing that's really nice with this is that you can run this, you can immediately take the array out, and then you can start plotting. So I'll play with the array a little bit to show you how it works. But
Is Sinan?
Yes.
There's an error that just showed up in the chat, and I was having the same. Oh no, it's different from the one when I try to execute the cell that the one that creates the results directory, I get all kinds of errors from that. It doesn't want to make that direct. It says that the directory doesn't exist, and doesn't want to make that directory for some reason.
I get that too.
I also got that, but what I did was I went back to cell number 3 and then executed every cell after that.
Okay.
Obviously.
One thing that I will say is this is optional. You don't need to run this at all. I wanted to show you that it's something you can do. You can just run this one and skip that cell. And it will run it in a temporary folder, and everything else will work fine.
I did do that.
I just wanted to show you that you can indeed put the file somewhere and keep them around if you wanted to. That is the main reason why I wanted to show that. You can also manually create a results folder and an SRI folder, and then just skip you can delete this bit entirely. So that might also help if you're having that problem.
I think it's just that it doesn't want to force make the directory when you try to write to it. I don't know why, but it wouldn't do it.
I only tested this latest version on VSL, so it might be something. I'm sorry if that's a kind of a Mac permission thing, maybe. I have no idea.
Okay.
Okay, but if the temporary folders thing works, you don't need any of that. If you want to keep the files around for later analysis, that's something you probably want to know that exists, basically. I will play with this data format a little bit to show you how it works. But one of the main things that I wanted to show is that how quickly I can plot everything. There's a bunch of cells that showed you how this worked. But at the end of the day, the only code that I actually executed was, let me copy paste this over here. So it is just this portion. This alone would be enough to plot everything you have. So if you have a BNGL file, you just, you do your imports, and then you have a single run, which automatically loads everything in. And then you would do one other thing. You would do this, would be the difference if I execute the cell. So of course, 1 second. Why did that do that? This is what happens when I do things on the fly. Yes, with Shift Enter. I know why. This is exactly the reason why I did it before. Give me 1 second. I know exactly what the problem is. This is why I mentioned that running it off of the output folder puts you under the folder that you selected. You need to. I changed the folders and it wasn't finding the BNGL file. But yes, this is the only portion that you actually really need to run these things, and it will run the folder. Wait. Oh. Sorry, I shouldn't be doing on-the-fly things. But I want to fix this really quickly to make sure that I got this right. This is correct.
So we don't have the results directory I mean, the results kind of a thingy that you have in the clone folder from Git, right?
Sorry?
We don't have the results within the workshop 2021 directory that we
Yeah,
cloned from
you
Git.
don't. Yeah, you don't.
Okay, so I was, yeah.
If you want that folder specifically, you need to run it like I mentioned earlier with the out equals results. You know, this section over here is what creates the results folder and puts the results of this run in there. That's why the results folder there. It's not necessary to do any of this. It's just to show you that you can indeed do that if you wanted to. Okay. Okay, there we go. I'm not quite sure what happened there. It's probably an environment issue, sorry. But it's basically just, I immediately loaded into a results folder. I pulled out my results and I immediately just did a plotting. So one of the things that I want to show you is that this R is just the NumPy record object, which this record array contains the entire file contents and also shows you what you can key it with. So you can key it with the time, which is the main thing. And then you have the 3 observables that you can key it with. And so if you wanted to say, do an analysis on the S observable, this will give you the entire time series for it. And with this, you can do automated plotting of the model. So now the next thing is, okay, so let's make sure that everybody is comfortable with this and there are no major issues. Unicode decoder on PyBioNetGen. I have never heard that. Michael, can you send me a message on Slack at some point with the error code? I would like to continue and I will figure that problem out.
If you read carefully there, it looks like it says auto.bng1.
Oh, yes. That should be BNGL. Is that a mistake that I made?
I'm not sure what line that's on.
It is the 16th cell, I believe, and I don't see it on my end. It should be BNGL.
Yeah. It
Okay.
looks like an L. It looks like an L to me.
Okay, so if nobody has any issues with the plotting portion, I want to talk a little bit about what the parsing portion of this library can do. Yeah, so one of the things that you can do with this library is to parse your model and you look inside it. At the moment, there's a couple major drawbacks. It does not parse comments and it does not parse actions. The actions portion will change very soon, actually. In a couple of weeks, it will start parsing actions. But for now, it doesn't parse actions, just a heads up. So when I do this, it will create a file and we'll read the results of that file in a temporary folder. So this is not the most efficient implementation of this. We are working on a C++ based solution for better parsing. Until then, this is reasonably effective, but once the C++ library comes in, we're hoping that this is going to be much better. And this model object here is written very much with BNGL in mind. So if you try to print this model, it will just print the BNGL entirely. You will see that it has no actions and it has no comments. This model object has multiple blocks. If you, let's see, go over here. If you call model.activeBlocks, it will show you which blocks that it has read. Why I read it multiple times? It shouldn't have that many. Sorry. I think I've managed to read it multiple times. Yeah, there we go. Okay, there was a mistake. If you print individual blocks, it is capable of printing blocks separately. And it actually behaves like a Python object like you would expect. So for example, doing for loops over blocks actually works really well. You can loop over blocks and you can look at, hey, I have a parameters block, I have a molecule type block, species block, observable block. I'm printing specifically the parameters and the observable blocks only. I didn't want to fill out the entire screen. But another thing you can do is loop over each individual parameter within a block. And actually each parameter will have its own attributes that you can manipulate, which I will show in a minute. But you have the parameter name and you actually have the value over here. Observables, you can do the same thing. So each block you can actually loop over, and it's hopefully all behave like you would expect from a Python object would. You can index them, you can loop over them. So this also allows for some really basic manipulation of the model itself. So this first line is just to add a particular action. This is just a simulation action that I'm adding. And I'm going to loop over multiple values, and I'm going to change the initial value of S. I believe this is what that was. So the initial value of S, and I'm going to change it from 0.1 to 1 to 10. And the observable I'm going to look at is S. What's happening here is that I added this simulate object to the model. I'm changing the parameters in the for loop, and then I'm running it. And this suppress keyword is to just suppress the BioNetGen output. You don't have to do this, but it just will not print the BioNetGen output if you don't need to, debug your model. The run also accepts this model object as an argument. And this result is, like we discussed, is the result object that you've seen before. So what I'm going to do is I'm going to plot the S result over all the values of I0. And like I mentioned, this running actually has to rewrite the BNGL file. So this is not the most efficient implementation. Again, for this type of analysis, we have another solution that I will talk more about in the advanced topics section. It's a temporary solution. Hopefully, we'll have a more tightly integrated simulators in this library eventually, but that's the longer term goal. But another thing you can do, for example, I can change this. I can look at I. Let me redo it. 4 different values of I0. This is the initially infected count, if I recall correctly. And then you can see how that impacts the results over time, over different parameter values. So this last one, I just wanted to talk about kind of how you can programmatically take a look at the more complicated structured species. This is not like a very crucial example, but I do want to show some of the fancier things you can do with this, or at least fancier things you will be able to do better eventually. The manipulation capabilities of the library is it's all there, but it's not very user friendly. So if you want to kind of make a model, or if you want to like heavily change and modify a model, I think you should be doing it off of just editing the BNGL file. But this will allow you to read anything you want off of the model at the moment. Eventually, we want to make it so that this will do error checking for you. So you will make a change and it will tell you, hey, this is wrong. You cannot do this in this model, that kind of thing. But that kind of capability is not there yet. So if you can still change a model drastically with this if you know exactly what you're doing. At the moment, it is not the most user-friendly way of doing it. Like I said, I suggest using the BNGL file, at least for now. And this giant for loop is basically going to loop over every single reaction rule. And I'm going to loop over every product and reactant. And I'm going to also loop over what's in each one of the products and reactants. So the first one is just to loop over the rules. I'm pulling out reactants and products. I'm going to loop over reactants first. Each reactant is what we call a pattern, which can contain multiple different types of molecules, that are bound together. In this example, there's none except, I think, a couple here. Yeah, it's just this one, I believe. Yeah, sorry, 2 of them over here. So it will loop over we can loop over all the molecules. And for each molecule, you can loop over every component. And each one of these things are actually just an object that you can change, manipulate, whatever you want. And you can individually take a look at them if that's something that you need to do. So I'm going to execute this line and I'll show you. So the first rule is this. Let me go down so that it's in front of us. Actually, I should have probably done it this way. And it's looping over the reactants. It only has a single molecule. You can look at the name itself. You can loop over every component, the component's names and its states. And you can do this for pretty much everything. Let's look at the more interesting one, the bound one. There we go. So if you look at here in the product section, I didn't loop over the molecules correctly, sorry. Mariam, you need to update your PyBioNetGen. You do pip install PyBioNetGen -- upgrade and try rerunning. But yeah, so basically this allows you to kind of go through the entire model in a programmatic fashion. If you need to just do reading, that's perfectly fine. If you need to do, I know exactly what happened here. There we go. I was confused about something. Let's look at here. Yes, there we go. Okay, I was worried that I made a mistake here. It's just my code here that is not the greatest. There we go. So if you look at this bounced one, for example, the K1 and P, in the products, this is a product section. The product itself is this entire pattern, and I'm looping over both molecules. So you have the K1 molecule, and it has the component. This is the full text for the component. You have the name of the component and the state of the component. You can actually look at the binding pattern as well here. And the second molecule that's bound to the first one is P. So you can separately loop over each one of them as well. Okay. That is basically all I wanted to talk about. These are the main features that we have right now in the library side of PyBioNetGen, PyBNG. I actually do want to show you one more thing from the command line interface. And that's to quickly show you how it might be useful for you. If I come over here. So in your terminal here, you have access to PyBioNetGen if you manage to run models. You can do -H in order to look at the help text. I tried to make this as user-friendly as possible. Please let me know if you have any suggestions on that one. PyBioNetGen, and then let's say you want to run a model, and you have three options here: notebook, plot, and run. If you wanted to run a model but you don't know exactly how, you can do -H after typing run. I will deal with this later. There's a new pandas and NumPy issue that popped up today, which I fixed, but it now gives this warning. But if you wanted to learn how to run each one of the subcommands, it will tell you exactly how to do so. There's some defaults that, if you wanted to say, I wanted to run auto.bngl, and if I don't give an output folder, it will just immediately put everything in the folder it's in. This is going to take a hot second. I should have run the other one. But this is one of the more complicated models to run. But there's 3 commands, and I wanted to mention, so the run is just for running. Plotting is for very simple plotting of GDAT files and CDAT files and scan files. The second button that you've seen in the plotting section actually uses that functionality. And finally, there's a notebook command. This is eventually going to be a very easy way for us to distribute potential analyses. Right now, you can do a notebook command and point to a model, and it will give you a notebook that you can run immediately. Let's say I want to have a notebook from this. And if I open the folder over here, I should have a sri.pyonb. Oh, there we go. The BNG notebook is the default name. So it will create a notebook for you that specifically refers to the model that you selected. It's very kind of bare bones right now. This is just kind of the base functionality that we wanted. So it will import PyNetGen, it will run it for you, that kind of thing. It's just to show you very basics of how to use the library. But eventually we will be adding different types of notebooks here with different analyses. So if you wanted to do a parameter estimation or something along those lines, you're going to be able to go to the command line, ask for the specific type of notebook, and start working with it immediately. That's the idea with that command. And as you can see from all the folders, all the file folders that are being generated, this is the result of the run command that I just gave. And the plot command you've seen with the other plotting tool is the thing that does this plotting. So if you click on this button, it will go over here and use the plotting tool to make a very simple plot for you. And it tries to open it afterwards. It's not necessarily the best way. I wouldn't expect that to work all the time. But it will, if it finds a PNG file, if the PNG file that it's supposed to be creating, it will open that up for you automatically. If not, you can look at it from within VS Code. Okay, so that is all I wanted to talk about. Are there any questions, first of all? Are there any problems that we haven't discussed during the talk? And are there any suggestions?
I was wondering, you went a little quickly. Can you do something like parameter sweep through that? I know you talked about it, but it was pretty fast. Okay.
Yep, this block does a very simple parameter scan. You can use the internal PyNetGen parameter scan action as well, and you can actually do it from here as well. It will give you the scan.scan file that you can plot separately. And that's actually probably the better way of doing parameter scans. This is just to show the kind of thing you can do. You can do actually implement very complicated analyses with this, but if you're running a lot of samples, this is probably not the way to go for something that's very complicated. We can change another parameter. Let's do a test really quickly. Let me go back here and make sure I've loaded it correctly. Okay, let's look. What are the parameters? Let's say, Jim, which one would be an interesting one to scan? Do you know? Do you have a suggestion? Okay.
Sorry, I'm being slow because
Okay.
trying to get the mute button. R0 is what we scanned before.
Okay.
So
We
that's
can-
going to scan the.
We can do that
More
as
interesting.
well.
Actually,
Any suggestions as to the numbers, or should I just go?
you could do 1, 2, 4 if you just want to do a couple, or you could do 0.5, 1, 2, 4.
Yeah, let's do that.
That's log scale.
You mean, oh, you want this? Okay.
It's fine. It's fine. No, I'm saying I'm just.
Okay. So this is going to take a second. Like I said, this is probably not the most efficient implementation if you want to do a lot of runs. But for quick things like this, it is actually really good. I really like this for very early exploration, quickly scanning one file, a couple parameters, quickly looking at the results of just to look at the time series of everything. Of course, I can store these somewhere, and instead of rerunning it every single time, I can just do an analysis on it. This is just me being quickly trying to manipulate things around to show you. But in reality, of course, I would store everything in a result folder and do my analysis afterwards. That is, that is a very interesting result. Can you also send me the problem you're getting on Slack instead? I need to take a look at that. I have an idea as to what it is, but I cannot debug it right this second. I will debug it immediately after this talk is over, which basically it is over unless there are any other questions.
I have a question.
Yes.
I'm not sure if I should have asked it during Jim's talk, and I'm really sorry if you talked about it. It's 10 o'clock in the evening in London now, so I'm really at the end of my concentration span. But it's about observables. So how many characteristics can we put into an observable? Is there a way of changing it using PyBioNetGen, or increasing the amount of things that we can observe in observables?
Basically, every observable that you put in will be outputted into the GDAT. So you can put quite a bit if that's what you want. Another thing you can do is you can actually put multiple patterns within an observable if that's something that you're interested in, to combine multiple different types of things that you want to observe. And yes, PyBioNetGen can change it around. It is not the most user-friendly thing right now, but you can do it by essentially just adding to this patterns list. In this loop I mentioned, there's this ODOT patterns. If you actually just append the string you want here, it will work. There is no official way that I've implemented yet in order to add these things quickly. There's also other functionality in the API to generate observables and adding them in the more correct way, let's say, so that everything like this works. But it's eventually the main reason why there's no major functionality like this right now is that I'm still waiting on the C++ parser that I mentioned. It will make things a lot easier to generate objects to put into the model object itself. Right now, I don't have a good API for users to create objects. And honestly, that's not necessarily the main focus of this library, but there will be a way to do it eventually, especially after the parser is complete. If that answers your question, is there?
Yeah, it does. Thank you.
You're welcome. It's doable. I don't suggest doing it that way. I suggest doing it through the BNGL file right now. Okay.
We will go over some, and especially Raquel, if you remind me, if you want it, when we discuss patterns a bit more, we can give examples of how you define multiple patterns in an observable, or use different wildcards to refine or expand patterns. Yeah. We haven't covered that in depth really yet. I my challenge. I hear you about it being late too. It's for me 4 or 5 o'clock in the afternoon after I've been talking half the day or more is late. So we may all run out of steam. That's okay.
Please let me know on Slack if you have any questions. I'm going to be there for a while.
So Sinan, I can confirm that I was able to run the notebook all the way through.
Okay, I'm glad.
Yeah.
Okay, so did the pip install through the cell work?
I didn't do it that way.
Okay.
I already had done a. Yeah. You wanted me to do the update. Yes, that worked.
Okay.
And then I was able to get the plot to work. And so now when I ran the notebook, it makes plots and does all the things that the notebook should.
Okay. If there are no other questions, I will start and go back to the answering questions through Slack.
Manning the help desk.
Yes. Right. Thank you very much for listening. Much appreciated.
Thank you, Sinan.
We would not find a lot of these errors just running it on our own machines necessarily. It's tricky.
Yeah.
That is a question. So do we have a next session on a different Zoom link? Well, I looked at the schedule and we have until 5:30 on this link, the way it's scheduled. 5:30. Yes, 2:30.
Oh my God! No,
I'm so bad at thinking in multiple time zones. We could 2:30 to 3, and then 3 to 4 is what the last session is scheduled for. And
this time zone is our revenge on you for always making us think in your time zone. So it's my turn to get even.
we accept that. I accept the Eastern Zone centric nature of Zoom things, and I don't mind it. I'm not complaining about it for the purpose of it should just be the one that's ours. But I'm just still I appreciate the issues that it causes because it's just constantly mind bending. It's what your mind tends to correct, and then the natural thing is it wants to correct again. And so you just you end up switching back and forth. So no problem. Well,
back in the 1620s, the Raj in Jaipur wanted Jaipur to be the center of the universe. So he put Jaipur on a half time zone relative to Greenwich. Anyway.
Okay. So what's the plan now? Are we going to have a short break or long break, or
I thought, like I said, I was trying to respect the schedule. I screwed up royally this morning, partly because I was time zone. I was trying, I was talking and trying to figure it out, and I think I miscalculated at some point. We ended up going an extra hour without the break, but which people can complain, But I saw some people being concerned because as I said before, if you have your schedule planned out to attend the workshop and you have another meeting that's in between that you already scheduled, we're trying to respect that to keep so that we don't. Respect your scheduling. But if we do mess up like we did a bit today, do keep in mind that we will have we will have these recorded, and you would be able to go back and listen to these again. And for a lot of the stuff that I presented this morning, it's really well scripted in those slides, so you can go through those examples on your own for sure. And feel free to Slack us questions if you run into any glitches. So I still haven't answered your question, Rosita. My plan was to go to 2:30 to the officially scheduled break time, take the officially scheduled break, and then gut out that last hour of just, let's go through as many models and concepts as we can, so that, people get to see it at least. I realize, people may be tired and whatnot, but I did want to give you guys a chance to learn the things that you're interested in learning about.
Okay, cool. Perfect.
So we can, what I didn't finish before was the example, our first sort of actual rule-based model. Where did it go? Hands-on portion. So this is where we stopped last time. And I like this example for a number of reasons, that of an autophosphorylating kinase. And I didn't go into full screen. I guess I could do that. It's an old model, and it wasn't originally framed as a rule-based model, but it's kind of fun to make a rule-based version of it. It illustrates the concept of structured molecules with binding sites and with component states. And this is one version of it. There are a couple of versions of it floating around in PyBioNetGen land. But the fun example of this is that not only is it a simple example model that shows how we can model catalytic reactions in part, but also it's an example of a bistable system, so we can check out what that means, and it's pretty fun, and it's very fast to code. So what the basic idea is that this is sort of a very schematic idea about how a molecule like CAM kinase 2 might work. And it's a kinase, but it's activated by phosphorylation, and it can be a substrate for itself. And I'm going to keep things, very general and call them K1, call the model the kinase K1, and not attribute any names to it, because that keeps me out of trouble. But so we have two states, basically, K1 that's unphosphorylated and K1 that's phosphorylated, and so we can represent that using our molecule types block that I mentioned in my talk, but we haven't actually made yet. And those will be the basic components of our model, very simple. So this just shows how we abstract. So the kinase just has a phosphorylation site so it can be unphosphorylated, phosphorylated, and then there's a phosphatase that attaches to the kinase and dephosphorylates it using a Michaelis type mechanism that we will code explicitly. So the way that this model is encoded is slightly asymmetric in the sense that it will come out in just a minute. But so there are two reactions that can activate the kinase, and one is just is meant to depict this arrow of this that's connected to a stimulus coming in. There's another kinase that's sort of implicit in this model that causes the kinase to get K1 to get phosphorylated. So we represent that as a reaction in which K1 gets phosphorylated, goes from Y0 to YP, and we just associate a rate constant with that transformation of S. And so we call that our input signal. So we're gonna look at the state of kinase phosphorylation as a function of this input S. And then once the kinase gets phosphorylated, then it can undergo a second reaction wherein the first kinase, the phosphorylated kinase can phosphorylate another kinase molecule. So it's an autophosphorylation reaction and produce a second phosphorylated kinase. So that's represented here. So we have the unphosphorylated kinase comes in, it interacts with the phosphorylated one, and it makes two copies. This should look very familiar. This is exactly the same structure as the infection reaction in the SIR model. And it's kind of a shortcut it would have been better to model this explicitly as a complex formation, but just to make it simple, the number of reactions, keep the number of reactions to a minimum, I modeled it as a bimolecular reaction. And for the purposes of illustrating the switch, how this can act as a switch, it doesn't matter. Okay, and then there are two more reactions involving the phosphatase that I put in all at once here, but let's go over them one at a time, because this is our first example. R3 is our first example of a binding reaction. So we have the phosphorylated kinase can bind to the phosphatase, and this is a phosphatase that's not bound, and form a bond between the Y component of the kinase and the B component of the phosphatase. And since this is now a reversible reaction, we have a forward rate constant and a reverse rate constant. And that's that reaction. And then finally, we have the actual dephosphorylation of the phosphorylated kinase. So once this complex is formed, the complex can either go backwards and dissociate to leave us with a phosphorylated kinase, or in the forward direction, it can become dephosphorylated and it releases the phosphatase enzyme. And I think it's important in this case, the reason that this is the sort of minimal model, it's important for the switch-like behavior of this system, for this phosphatase to act under conditions of saturation, meaning that we can drive the signal, we can make S large enough that there's enough phosphorylated kinase around that the phosphatase can't completely control the level. So, and I can go into more mathematical details about what that means. But so here's our PyBioNetGen model description, and we can put this into VS Code ourselves. It's probably a good practice to make sure to do it. Just walk through. It shouldn't take us very long. And then the one parameter, the way I've encoded it. So one feature of the way that I encoded here, I use numerical values explicitly for all the rate constants, just to minimize the number of parameters we have to define, because sometimes that actually complicates and confuses the model definition. So there's only one parameter in this model, S, the way that I encoded it. And then there's two species initially. The unphosphorylated kinase we start with, and the phosphatase, and that's that. And then and the observables is the last block we have to define, and we just make the observable be the phosphorylated kinase, and we called it K1P. So I'm debating with myself. Let's see what the time is. We have 10 minutes or so to walk through the rest of this. So we can kind of cheat, I think. Why is my, let me see if, go to VS Code. We can, so we were working with this model if you guys have your PyBioNetGen up already, then we can actually, this in a way demonstrates a little bit the flexibility of the interface. So we have this model already coded up in the PyBioNetGen directory. This is I think it also exists one directory up. I put a version in as well, but let's just work with this one for now. It has all the commands we're going to need. I don't remember why I defined this input, but okay. The only thing you'll notice I didn't, for some reason, when I made this, I didn't indent these. I'm just gonna clean that up for the heck of it. You'll see that I pulled this version of the model, and since I've cloned this repo, version control is on and it's tracking all my changes to the models, and it's wanting me eventually to stage all the changes and push them back up, which we won't worry about right now. Okay, so yeah, and there's some cool stuff in here that we can play around with later on if we want to, but before we do the parameter scan, let's just look at the basic, what happens in this model. Oh, and I actually use this. There's some extra stuff going on here. We'll just ignore it for the time being, and run the model, and then we can discuss advanced things later on in the program. So everything should be set, and we should be able to just run. Oh, except there's going to be an error at the end. Ooh, what was that all about? Conda activate base.
The conda activate base is normal. The other one looks like a badly formed action command.
Yeah, no, I knew that. I saw that at the end because I forgot, because I missed. So when I commented these out, I can show you a trick really quick. When I commented these lines out, I missed the continuation because these have continuation lines on them. So just to demonstrate that. So if I copy the whole region, if I highlight the whole region, select the whole region, and do command / that should be /, it will comment out the region. So that's a safer comment. That would prevent that error message from happening. Fortunately, PyBioNetGen executed the lines above that before it got to the error, and so it actually ran what I wanted to run. But and so now we have our time course, and we can make a plot. And I defined this extra variable, the input, which we don't need for this. That's just to demonstrate the function display. Double click. And we could just see the very simple dynamics. This is time on the x-axis and the concentration of K1P. It comes up and it reaches a steady state. And it's almost gotten to a steady state by 50 seconds, but it's not quite long enough to reach steady state for this case. So there's a steady state level. And so if we remember, for these conditions, there were 100 kinase molecules, and only a little less than 2 of them are phosphorylated. So we're at a pretty low state of activity for this signal input value. What's interesting is if we, I believe, and I hope I'm correct about that, pretty sure I'm correct. If we, instead of starting all of the kinases in the phosphorylated state, unphosphorylated state, if we instead start them all in the phosphorylated state, then we can see something interesting happen. So remember, this was we have the steady state of low activity here. Now, if we run it, if this model, under normal situation, the steady state wouldn't depend on the initial conditions. We have exactly the same network with the same parameters. But here we start with all the kinases phosphorylated, and what we can see when we plot this is that right. So at the end of this, actually the steady state occurs very rapidly, much more rapidly than that 50-second time scale. We see that most of the kinase remains phosphorylated at the steady state of about 80, a little less than 80. So something interesting is happening here, that there seem to be maybe 2 different steady states, and we might want to just to be on the safe side, since we can do this easily, if we go back to the lower one and just, let's make sure we didn't miss something. And actually, I'm going to just comment this for a sec, just to make my life a little bit easier. Let's go to 500 instead of 50, just to make sure that we didn't miss something happening, because sometimes steady states can take a long time to reach. So, okay, I think this pretty well proves that the steady state of this model is low when you start it at low, and it's high when you start it high. So it's like 78 when you start it up at 100 versus 2 when you start it at 0. So, so this model is exhibiting something called bistability, which means that it's it's steady state. There are multiple steady states. So the bistable, and which steady state we end up in depends on the initial conditions of the model. And so that the idea that why Lissman thought this was interesting was this provided a way to have a switch. So if you could stimulate the kinase in a way that activated it, and then it remained in an active state once you remove the stimulation, then you could have a memory dependent or system state. And how to get this out of a simple biochemical circuit was the question that he was asking. And let's go back to, so how do we investigate the dependence of the steady state on the S value? So one thing the first thing that we could do is make a parameter scan. We could just scan the parameter value with S. And we learned how to do a parameter scan before. I think I knew that. Option Z makes word wrap happen. So we could do a parameter scan here and see how does the steady state change. If we start from a low state of activity, can we get this system into a high steady state level of activity? And yeah, it doesn't recognize, I don't know, maybe Sinan should comment on this at some point, but it doesn't recognize scan files by default, doesn't automatically open scan files. So we have to,
I'll fix that like really quickly.
Yeah.
In 10 minutes or something. It just doesn't search for it.
Okay. Beware of that quick fix, because I can imagine how searching could cause problems. So when we do a parameter scan like this, and you see this very sharp jump. So as we increase S, what we see is that at some threshold value of S, the steady state goes from being a fairly low one with a low percentage of activity up to a very high one over what seems like a very small range. And I turned the point plotting on here so that we can see that these are neighboring points where this happens. This parameter scan doesn't catch any points on this rise. And that's a hallmark of a very steep switch. I mean, if I made 1,000, if I tried to sample this very narrowly across the interval, I could eventually find intermediate points, but the switching happens almost instantaneously as a function of the signal input. So this is a switch-like system. It exhibits a very sharp threshold kind of behavior with respect to S. And what we know is this upper steady state, it becomes the only steady state, or it becomes the steady state that's accessible from a low initial value at this threshold of what looks like, okay, so I can actually track the exact value of the point in my Plotly, which is very nice, at just about 0.01 in signal input. So about halfway to 0.0, between these 0 and the grid line here. And then it switches to the upper steady state. And a hallmark of a bistable system is that then if we then relax S slowly back down, we know that there should be another steady state up here, because we saw it when we did the simulation starting at high initial kinase phosphorylation. So we can track out the upper steady state here if we slowly relax, if we slowly scan the parameter backwards back down. So it's pretty easy to do this. BioNetGen actually provides an additional command that will do a sweep of a parameter up and down to help you identify bistable regions. And actually, yeah, Sinan ran it earlier before when it was a nuisance, but it's actually a feature. So we can put this, I'm just going to join these all into one line. And so we can use this command that's called bifurcate. And it essentially we can, it's essentially the same syntax as parameter scan, but instead of just going up in one direction, it goes up and down. And I can't remember if you can do a backward parameter scan by setting par min higher than par max, or if PyBioNetGen gives you an error when you do that. There are ways that you could, the other thing that bifurcate does is that when it's scanning in a particular direction, rather than starting the system from the initial condition that you give up in the seed species block, it uses the final concentrations from the end of the trajectory from the previous parameter value as input to the next one. So it very much accelerates the finding of the steady state values. So this is a nice way to look at look for a system that's bistable. Oops, just trying to get rid of the extra space there so we could run that. And it generates, this is, we picked 50 scan points, so it's gonna generates a whole bunch of output files. And again, it doesn't launch automatically, but if we go in here, we'll find a scan file. And we can pull that up. And what the scan file has in it, so if we just go back for the first scan file, it just shows the steady state value of an observable that we specified as a function of the parameter that we swept, S. If we look at the, I've got just too many things open here. Oh, I guess I didn't. Let's get rid of that one. I didn't leave this one open. So if we look at the scan file that's generated by the bifurcation, it's a little different. It's got the value of the steady state value in the forward direction. So tuning S, going increasing S, and then on the other side, decreasing S. So it maps exactly the same values, but starting from different initial conditions. And we can see if these two columns are different, then we found a bifurcation. We found a bistability. And if we plot this, well, we can see that going in this forward direction, we encountered this threshold, we switched to the upper steady state, but then coming back down, there's a region here where this upper state is still stable. And so we come back, and even by zero, basically with zero signal, there's still an upper steady state for these parameter values. So we have made a nice irreversible switch. We can't make S small enough that it will switch back down to the lower steady state. We need some other mechanism to turn the system back off completely. So one way to do that might be to increase the phosphatase concentration temporarily to drive down the phosphorylation. And if we reset, even if we reset it back to its initial value, it'll stay down in that lower state for a while. I've gone over time, so when we come back, I'll show one more thing about this autophosphorylation system, and then we can talk about some other stuff.
Okay, thank you very much. So we will come back with a new Zoom link. Thank you.
New link. Okay, so we're going to be signed off.
Oh, if you want, we can stay on this one. It wasn't very long. If you want, we can just.
No, we'll just keep it. So it'll be much easier than to put them back onto the schedule.
Perfect. Okay.
Great. We'll see you in a few minutes.
Okay. See you
at the top of the hour.
Sorry.
Yeah, I think people are leaving anyway.
So should I share the next Zoom link in the Slack, or everyone knows already?
It wouldn't hurt to put it on Slack.
Okay, cool. I'm in.
Okay.
So I'm going to close this one if it is okay with you.
Okay.
See you in a few minutes. Bye-bye.
Okay.